Hello, everyone, and welcome to a brand new series called Data Structures and Algorithms Using Python. So, in today's video, we're going to be looking at what are the common data types and data structures that are available in Python. So, let's get started. All right, so we have four different major data types that are available in Python. Okay, so the first one being the numeric type. Numeric types have three different classification. One are the integers, so our integers are the numbers like 2, 3, and all that. Floats are going to basically be our decimal digits, right? So 2.3 and 4.1 and so on. Complex numbers are imaginary numbers. So like imaginary numbers are anything that has a root over a negative number. So let's say root of -2. And so like for example, they'll be of the form, let's say it's a 3i plus 2, where I is going to be our imaginary number. And then we have dictionary. So dictionary is basically going to be the hash map that we have. So I'll be going over what a hash map is, what a dictionary is later on in this video. Then we have sequence types. So sequence types are essentially like your array type of data structures. For example, you have lists, which is similar to arrays in other languages. You have like tuples, and you also have strings. So let's say this is a string. And apart from that, we also have a different data type called a set. Okay, so we'll be going over what each of these like data types are in detail in this video. Okay, so now again we have these four types of data structures that are implicit or built in, right? In Python, we have a way to import any kind of like data structures, a lot of different modules, right? We have the NumPy module, which can be used to import arrays. We have an array module as well, which we can use to import arrays. But these four that are shown here are the implicit or the built-in data structures. So the list, tuples, dictionaries, and set. Okay, so now we'll just see how to initialize each one of these like data types and data structures and see where it is used. All right. Okay, before we go ahead, I'll also just quickly explain what editor I'm currently using to add all of my code, so that even like if you're a beginner, then you can also understand and get started. Right now, I'm using the Google Research Collab. So basically, in Google Research Collab, it provides you an online version of a Jupyter Lab type environment where you can add your code, you can add markdowns. So if we see here, I can add different types of code or text. So in text, I can add, I have different markdown options. Similar to how you would add a README file in GitHub, you can add all of your comments, your tables, and everything's here. So all of your documentation, or you can simply add code here. So like you can just add some code like print hello. Okay, and you can just execute this, and this will work. Okay, you can execute the code cell by cell, and since this is an online editor, you can also share this with other people. You have the option at the top right here, and all of this will be saved into your Google Drive. So I will be providing the access to this particular Google Colab to you as well in the description, so that you can also go through, and as the tutorial goes, I'll be adding all of my content in this Google Colab note here. Right now, I've created a separate section called common data types and data structures in Python. So you will find all of the code that I'm going to explain in the tutorial underneath this particular section. Okay, so yeah, right now I've just executed a simple print statement. Let's have a look at how we can use our different variables. So Python is an interpreted language. Okay, so like interpreted means it executes line by line, and it is a dynamically typed language. Okay, let me just note that down here. All right, so I've added what interpreted means. Again, interpreted means that the code is going to execute line by line rather than the entire code being converted into machine language and then being executed. In terms of being dynamically typed, variables are assigned the data types during runtimes. So, unlike other languages like C, C++, Java, where you have to explicitly declare the data types, right? So, for example, in C++, you would say int a is equal to 10, right? And what this would mean is that you are explicitly saying that a is going to be an integer and you're assigning it a value 10. But here in Python, it is going to be like dynamically typed. So here you would simply say a is equal to 10, and the during when the code is getting executed, that is when dynamically the data type is designed based on what values are assigned to the variable. So later on in the code, I can also type in a is equal to 10.5, sorry, 10.5, and this would also work, right? This won't cause issues, so I can just execute it real quick, print a, and I'll write a print a as well, and you'll see that both of these are getting executed. This is because, again, since they are like dynamically typed, you can assign any type of data to anything. You can assign a string, so to add a string you can just say a is equal to Lennox, and then you can just give a print a here, execute this, and this will work. And by the way, to execute the cell, I'm just hitting control enter, which is a shortcut to execute this particular cell, or you can click on the run cell button here, which will also execute it. Okay, so for so this is what we mean by dynamically typed. And in this example, we have shown how we can assign an integer, a float, as well as a string here. Now let's just have a look at some of the properties of each of them. Okay, so here the main properties that we're going to see is first for string. Okay, again, so to initialize a string, you can just have a variable, let's say s, and you can give a name or like anything enclosed in a double brackets or a single quotes. Both of them will work. So this will also work, as well as if I'm adding it in single quotes, this will also work. All right. And the main properties of string are it is immutable. So when we say it is immutable, you cannot change the value of a string. So if I'm trying to change a character, let's say I want to modify the first character. So to access the first character, now normally in arrays or list we can give s of 0, because a string or an array is 0 indexed. All right. So when I say s of 0 is equal to, I want to change it to, let's, instead of an l, I want to change it to an a. Now if I try to execute this, like, this will give us an error that string object does not support item assignment. Again, so this is because strings are immutable, it cannot be changed. You cannot change the values, so cannot be changed. You can assign or append values to a string to create a new string. So this will essentially create a new string, it won't change the existing string. So for example, if I want to add my middle name as well into my name, so I can give s is equal to s plus, I'm going to add my middle name as well here, Sherwin. So now if I print s, you will see that this will add my name here as well. And if I want to add a space here, I can just add a space here, and if I click on print s, this will also work. And another short form for appending anything, like for integers, floats, or anything, you can give s plus equal to, and then you can give the name. So let's say I give this. So this will also work because you are essentially just appending the values. Okay, sorry, let me just print the value here, and you'll see this is getting added again. So this is just a short form way of saying s is equal to s plus something. You can just give s plus equal to this name. Okay. Okay, so before we move ahead, let me just explain what is slicing. As I had mentioned, slicing is a way to select a part of the data. So let's say we have a string s is equal to hello world. Okay, let me just write this down. So all of this we can access it based on like indexing. So all of this is zero index. So the index begins from 0, 1, 2, 3, 4, 5 for the empty space here, 6, 7, 8, 9, and 10. So we have a total of up till index from 0 to up till index 10. Now if I want to access only the word hello here, I essentially need to just pick index 0 to 4. How we would do this is that we can say print off. So we can print the s. So to access this, we can use the slicing method. So what we're going to do is we're going to uh, select from index 0 to 5, and so this is going to be uh, the the syntax for accessing it. So we're going to give the start index, we're going to give the end index, as well as we're going to give the skip value. Okay, so in this way we're going to do this. And so how this is going to be, this here we're going to give the first index from which we want to select the value. So in our case it's going to be 0, so we can say s of 0 comma sorry, not comma, we have to give colon here. So s from 0 to then the end. So for the end index, we have to give the end index excluding the last value. So for example, we want to access till index 4, but so for that we have to give the value 5 here, so that this will exclude 5, so this will be up till 5. Okay, got it, right? So from 0 to 5, so this will give the values up till 5 but won't include 5. And by default these skip values 1, so it'll go one by one. But let's say if you want to select every alternate value, you can, let's say, give 2 or something. But in our scenario, like, we can leave it as it is. So if you print s of 0 to 5, this will print us hello. Another shortcut is that if we want to get all of the values from the beginning, okay, then we can just say, instead of s of 0 to 5, we can just give colon 5. And this would essentially mean that we're fetching all of the values from the beginning up till 5. Okay, and same thing for if we need to select from a particular index till the rest of the string, right? So let's say we want to select world. Now if I want to select world, this is beginning from what, index 6, right? From index 6 until the end of the string. So to print world, I can give s of from index 6, so this is including 6 till the end. So either I can give here index 11, or I can just leave it empty as it is. So s of 6 colon empty will give us the value world. All right, so this is how string slicing works. It's a similar concept with arrays as well. I'll explain it when we come to arrays. So right now we're printing the s from the beginning until the fifth index, right? So this will print as hello because this is going up till here. Same thing if we want to print world now, as I had shown, we can give print s of from the sixth character, right? From the sixth index. So 0, 1, 2, 3, 4, 5, sixth index will begin with w until the end. So we can just give s colon this, and this will print world. Got it, right? And here if we want to access the individual characters, we can just give only that. So let's say we want to access the first index, or basically the second character, so we can just give 1, s of 1, so this will print us e. So this is how slicing works. It's a really handy tool to select a particular part of a string or a list, or like any type of iterable data that we have, even tuples. So this is how we do it. Okay, lists are similar to arrays in other languages. Okay, and we essentially can declare a list like this. So let's say l is equal to, I'm going to, in square brackets, give some integers. But the advantage with lists is that we can also have other data types. So I can have strings, I can have floats, all of that in the same container itself. So right now if I give a print of l, you'll see that this will work properly. In other languages, you might see that arrays have a single fixed data type, but in Python, you can have any type of data in the list. Now, to access the elements in this, it's in a similar way, they are zero indexed, as you must be aware. So if I give L of 0, you'll see that we're getting the value 1. And if I want to print the string, which is 0, 1, 2, 3, the third index, I can give L of 3, and you'll see this will print the value. Okay, got it, right? So this is how we can access it. And in a similar way, if we want to slice the values, okay, we can say print the uh, L from the beginning till, let's say, the third or the fourth index. So this will just print a subset of the values. Or we can say print from the second index to the fourth index, and this will just print from the second index, which is 3, till the fourth index. All right. Okay, so some of the properties of lists are they are mutable data. So when we say they are mutable, you can change the data. So for example, if I want to change my the string into a different string, right? So I can give L of, this is going to be my 0, 1, 2, 3. So my third index, right? So I can directly give L of 3 is equal to Sherwin. Let's say I'm just going to change this. I'm going to try to print L. and you'll see right now the name has been changed from Lennox to Sherwin. So this is a mutable type of data. You can change the values, unlike a string which is immutable. Okay, that's what immutable and mutable means. Okay, and another thing I need to show is how we can access the values of a list. So we can run a for loop through each of the values. So to run a for loop, we can just type in for a val. So this can be named anything. We can say for I or whatever. So right now I'll just call it for val in the list. So basically in L, we can directly just say print the val. All right, and this will print each of the values that are present in the list one by one, and so this is how you can access it. This is the same for all iterable values. So even for a string, let me just go here and show. So if you want to access each value, I can say for the val, or I'll just say for character C in S, we can give print of C. And so what this will do is this will print each value, it'll loop through each value in the string and print it one by one. Okay, so this is how you use the for loops to print each values in an iterable type of data. Next, we'll have a look at what is a tuple. Now a tuple is similar to a list. Okay, but here the main difference between this is that this is an immutable type of data. So immutable means that it cannot be changed, right? Similar to strings, cannot be changed. So once a tuple is created, you cannot change it. So for example, I'll just say t is equal to, in normal parenthesis I can give 1 2 3 4. Okay, and if I try to uh, let me just first print t, and you'll see this. Another thing I want to show you is that you can check what type of data is using the type function. So I can give print a type, and in brackets I'll give t. So this will print what type of data this particular variable is. Okay, so right now this is of type tuple. And now if I want to change a value, let's say similar to how I did for a list, I'm going to try to change the first value into a different one, let's say 10. And if I try to run this, this will give an error. Again, the same error as string, that it does not support item assignment. So let me just comment this out. And so the advantage of a tuple, where you would use a tuple, is that it is faster than list. Why it's faster? Because it is read only. Data is stored in a contiguous block rather than, so in a list they can be stored in different places in the memory, and since they are editable, lists are generally slower, but a tuple is best suited for when your values don't change. Then you can put it in a tuple. They are much more faster to access since they cannot be changed and they're stored in a continuous manner. Okay, so right now if I run this, this should just work. And this is how you can do this. You can also convert a list into a tuple. Let's say I have a list of 1 2, let's say, okay, 12 3 and 4. So this is a list I have, and I can also convert this into a tuple. So I can say t is equal to tuple of L, and I can print t. So this will convert this list into a tuple. And now we'll have a look at dictionaries. Okay, dictionaries are essentially hash maps. Okay, what are hash maps? They have key value pairs. All right, key value pairs, and here each of the key is indexed. So in the background they have different algorithms. So either with a balanced tree, balanced tree, or basically a b tree, or you have like different algorithms as well to create hash maps. And the advantage of a hash map is that they are used for efficient retrieval. So you have o of 1 retrieval, don't worry if you don't understand what o of 1 or how to calculate like time complexities. I'll cover all of this in detail in a later video. Right now just understand that uh, you can access the any value in a hash map really quickly. Okay, so you have fast retrieval. Okay, so that is what a dictionary means. Now so they're stored as key value pairs. So let's say to initialize a map, I'll just say map is equal to with empty curly braces. So this will initialize an empty map. And or I can even say map is equal to, let's say, or I can even give an assignment like a key. So the key, let's say I want to have the key as name, and I can say my name is Lennox. I want to add another value. I can say age is 26. So in this way, you can initialize a map as well. And to access the values in a map, you can use this syntax. So you can say for key comma val in map dot items. So I'm going to give the name of the map dot items function. This dot items function will expand the map in terms of keys and values. So you can say print. Okay, so I'm going to print the key. Key is key, and value is val. So now if I execute this, you'll see that it loops through each of the key and value. So the key is name and the value is Lennox, key is age, the value is 26. If I want to add a new value into this particular dictionary, I can just say map of, let's say I want to add one more parameter, location. Let's say I'm adding a location. I'll give this as map of location is equal to India. So now I can execute this, and you'll see that this is also now added as a new key value pair in the map. And to access a particular value in this, I can say print map of name. I just want to access what the name is. You just need to enclose this in either like single quotes or double quotes. Okay, you can give print map of name. This will print my name, Lennox. And this retrieval is extremely fast, as I had mentioned. Okay, also let's try one more thing to show you guys. So let's say I'm trying to access a particular key that is not available. So let's say I want to access the map of address. Right now we don't have an address key here. So let's see what happens when we execute this. You will see it's giving us a key error that address is not there. So to overcome this, what we can use is, whenever we're trying to access a value, you can say, you can use print map dot get, and then here you can give address. So what this will do is that if the value is not available, then it will return a none. A none variable is basically a null type here. So this will return a none. Otherwise, so if in the code, what you can essentially do in your data types is that you can say if map dot get address, you can do this. So in this way, sorry, we need to enclose this in single or double quotes. Then you can access the value. So you can say map of address, and let's say I want to do a print of this, print map of address. Okay, else you can just continue, or you can probably assign a value. So else you can say map of address is equal to, again we'll just give India here, and then later on you can print this. Now this won't give an error, so print map of address. Okay, so now you can see that this is working properly. So essentially, like, what we can do is we're just doing a check to see if map dot get address, if it is there, we can access the value, do some operations on it, else we can assign it. Okay, this is a common pattern in terms of dictionaries. And I'll also go through a lot of other common uh, techniques that you can use for in terms of like competitive coding. Some we'll also solve some problems as well in later videos. And finally, let's just have a look at the last two data types here. One will be the set. Okay, so this is how you initialize a set. It is similar to a hash map. And so right now you can see I've initialized a set with the same curly braces we use for hash maps. And here I've given 1 2 3 4 and 4. So I've given the value 4 as like duplicates, and when we click on when we hit print s, you will see that over here it removes that duplicate. So right now it's printing only 1 2 3 4 without the duplicate 4. So here I've shown another use case of this. So let me just comment out everything so that it's much more clearer. Here what I'm doing is that I have a list with a duplicate value. So in order to remove the duplicate and print only the unique ones, I'm first converting this into a set. So I'm saying set of this list, and I'm converting it back into a list. So if I just execute this right now, you'll see that it returns a list with without the duplicate values. Now to add new values, I can say s dot add 5, and then if I run this, you'll see that this will add the number. And to remove values, I can give s dot remove, and if I print this, you'll see this will remove the value. Okay. And since this is using hash maps internally, this is really quick. It's a really fast way to access values and perform operations. Apart from that, you can also perform values like perform like functions like union and intersection. So for example, I have s1 with these values 1 till 4, s2 which has values from like 3 to 6. If I run print s1 dot union s2, what happens is that this will consolidate all of the values, the unique values from s1 and the unique values from s2. So if you see, it has all the values from 1 to 6. Similarly, if I want only the common values between s1 and s2, I can simply run print s1 dot intersection s2, and this will, let me just execute this. This will execute and give me the value 3 comma 4, which is basically the common values between s1 and s2. Finally, let's have a look at boolean. So to like initialize a boolean value, you can give a is equal to true. Let's say you can just use the true and the false values. Okay, so you have to use the capital T and capital F. And if I just say if a print yes, let me just execute this. So right now what this will print is yes, because a is a true value. All right. And but if I, let's say, I'll just give here one more thing. If b print, I'll just say false. And let me execute this. You'll see this won't print anything. This is because b is false, so this won't go into this if condition. If I want to actually print this value, I can give the if not b. So this is how you give a negative condition. So if not b, then now this will print false because b is actually false. And in order, in a similar way to like simulate boolean, you can also give for false, you can give 0. If you give b is equal to 0, it will work in a similar way to saying it's false. Or you can give any positive integer for a. This will positive values for a, and this will also work as true. So like any positive or even strings, if you just give if a and a is a string, this will also work. Okay, so these are the data structures and data types that we had a look today. This is going, this will be a longer video because I wanted to explain all of the data types and data structures in one video. So in the upcoming videos, I want to cover all of these different algorithms. So linked list, the different sorting methods, hash maps and details, how we can do dynamic programming, recursion, classes, oops concept, and anything else that's related to competitive programming with Python. I want to create a detailed series. Thank you so much for watching this video. If you like this, please like, comment, share, and subscribe. And let me know down in the comment section below on what you would like to see next. Your feedback really means a lot to me and helps me to improve my videos as well. So thank you so much, and I'll see you all in the next video. Bye bye.